In this exercise we will learn how to do polynomial fitting into discrete data and how to solve the roots of the resulting polynomial. So the data in this exercise can be illustrated by this animation. So imagine that we have a ball that is thrown from the ground upwards, and then it goes to the peak value of the path, and then the gravitation starts to pull it down. And imagine that we have measurements only until 8 meters horizontally, and we would like to know where exactly does the ball hit the ground when it reaches the ground. And we have a perfect model for this data because gravitation is described by a second order acceleration, so we can fit the second order polynomial to fit the model quite well. So what we want to do is to fit the model to have a description, second order polynomial that describes the path as well as possible. And then finally we would like to know what is this point, what is the x coordinate of the point where the predicted trajectory hits the ground, what is the root of the polynomial in here. And that can be solved in Matlab also quite easily, and the result in this case would be something around 10 meters. So how to proceed? Here is a template of what you should do. First, download the data file from the web as described in the instructions. Then you can open it in Matlab using the load command, and this loads a workspace that has two variables, x and y. X contains the x coordinates of the flight path, y contains the y coordinates of the flight path. And these can be easily plotted using plot x and y, and in here I'm plotting with circles to illustrate that it's actually a discrete set of points, not a continuous curve. And then I also increase the line width to 3 points instead of the default 1 in order to make it better visible, at least in the video. You may omit the last part if you wish. And then I set the axis of the plot to be a bit wider than they are by default. So what I say in here is that I want to have the range of x values in my plot between 0 and 11. I want to have the range of vertical values between 0 and 13 in my plot. So y-axis extends from 0 until 13 to have a bit more space. Then I state the hold on command, which allows me to plot later on the same figure. I want to plot the continuous curve on top of the individual points. So without this, the next plot would wipe out the original data. Then the actual fitting. There is a ready function for this in Matlab called polyfit, and I ask you to see here help for usage, but basically what goes in are the data. X and y go into the polyfit command, and as a result you will get a set of coefficient. Also what is needed for polyfit is the order of your model. So do you want to fit a first order, second order, third order polynomial or what? And obviously in this case second order is the correct solution, but maybe you would like to experiment with other orders just to see how it works. First order, second order, third order might be interesting things to try. Then you want to plot the polynomial, and the problem with the original data is that I have only x values from 0 until 8. But then now I would like to see what happens after 8. So that's why I need to make another x vector for the next plot, which is done in here. So in here my x new will contain values from 0 until 11. The linspace command is a nice utility for making vectors where the values are linearly spaced between the start point and end point. And in my case the start point is 0 and the end point of the axis that I'm interested in is 11. And the third argument says that I would like to have 100 equally spaced points between 0 and 11 in this vector. Once I have created the vector of 100 points between these extremes, I want to calculate what are the values of my polynomial in this range. So I use the polyval command, which is a companion to the polyfit, and to polyval goes the coefficients describing the polynomial as such, and the data, which is the x new. But please see the help for more accurate usage to see how it actually works. And finally, I want to plot my new x from 0 to 11, my y, which are the values of my new polynomial in this range, and I want to plot it in red solid line. And the last task of the assignment is to solve where the curve hits 0, where the ball hits the ground, or what is the root of our new polynomial. And this can be done in Matlab using the roots command, which as the name says, it calculates the roots of a polynomial. This also works with same kind of representation for the polynomial like before, like as a vector, like in polyval and like in polyfit. Basically, these are the coefficients that go in to the roots command. But see help for further usage. And once I have calculated the roots, I want to plot one of them. And actually, I'm plotting the rightmost root, because this polynomial has two roots. One is here at 0, and the second one is here at 10.2 or something. And I'm only wanting to plot this one, not that one. And that's why I'm plotting only the larger of the two roots. R has two components, and I want to plot only the larger one of those. And at that x coordinate, my y coordinate is 0, because that's the ground level. And I want to plot this individual point by using a green circle and with line width slightly extended from the default one. So basically this describes what were the tasks, and please extend this template shown in the video to a fully working Matlab script and return it by email to the according to the instructions shown in the assignment text.